This is the team project demonstration video for the Secure Password Manager team. Our team is me, Kat, as well as Spencer, Brandon, and Roman. For our capstone project, our team set out to build a secure web-based password manager that balances usability with strong security practices. Our primary goal was to create an application where users can register an account, log in securely using multi-factor authentication, and manage their credentials through an encrypted vault. Another key feature was a password generator that helps users create strong, unique passwords rather than relying on weak or reused credentials. Security was a major focus throughout the project. We implemented encryption and other protective mechanisms to ensure sensitive credential data remains secure both during transmission and while stored in the system. Also, we wanted the application to be accessible beyond a local development environment, so we deployed it to the cloud and created supporting documentation and user guides to help users understand and interact with the application. Throughout this video, we'll show how these goals were translated into a working product and discuss the technologies and development decisions that made it possible.
Okay, so this is our app here, the Secure Password Manager. So the first thing to do would be to register as a new user. So I'm just going to register with some test credentials here. And then just enter in a password. And then when I register, it gives me my secret key, which I would then add to the Google Authenticator app, which I will do now. Okay, so I have my key added to my Google Authenticator app. So I'm going to go ahead and log in. And this is just some spam email that I have. Let me just log in with those credentials that I registered with. Then when I log in, I'm going to have to enter the OTP from the Authenticator app. And then it logs me in. So now that I'm logged in, I have the ability to add a new password to my vault here. So just add a GitHub password here, and then my username, Brandon, and then the password. I'm actually going to use our app to generate a new password. So I can generate a length, let's do 32. Let's generate that password. And then I'm able to see the password here and then save it. And then we can see it's saved right here now. And then if I want to copy the password, I can just click copy, and now it's copied. I can just paste it there to show you. Go ahead and delete that. Then I can also delete passwords. So I have this test right here. Let me just delete that. And now it's gone. And then I also have the ability to edit passwords. So if I go ahead and edit a password, let's change this name, username. Just username, I guess. And then we can save that. And there we go, it updated right there. And then we also have the ability to search. So if I want to look at my GitHub passwords, just type GitHub, and then it only shows the GitHub passwords. Got rid of that bank one that I had in there.
Kat again. My primary responsibility on the project was designing and implementing the front-end security architecture. Early in development, I researched client-side encryption approaches and ultimately chose the browser's native web crypto API. I then implemented our encryption workflow using ASGCM for authenticated encryption and PBKDF2 for secure key derivation, and integrated that workflow with the backend API so credential data is encrypted before being transmitted or stored. Beyond encryption, I developed secure front-end state management, implemented the password generator feature, added handling for edge cases and validation errors, and created automated tests to verify functionality and reliability, as well as authoring front-end architecture and other technical documentation. The primary technologies I used were React, the Web Crypto API, AES-GCM, PBKDF2, and React Testing Library. React provided the front-end framework, while the Web Crypto API enabled browser-based encryption without relying on third-party libraries. AES-GCM was selected to protect both the confidentiality and integrity of credential data, and PBKDF2 was used to securely derive encryption keys from the user's master password. And React testing library was used to validate the security related functionality through automated testing. So one significant change from our original project plan was moving away from a third-party encryption library and instead using the browser's native web crypto API. This required additional research and implementation effort, but it improved security by reducing external dependencies and aligning more closely with modern web security practices. One challenge was learning how cryptographic systems work beyond simply calling encryption functions. I needed to understand key derivation, initialization vectors, authenticated encryption, and how to safely manage sensitive data within the application lifecycle. Another challenge was handling edge cases, like updating records, empty fields, and ensuring encryption and decryption remain reliable under different scenarios. But overall, this project gave me hands-on experience designing security-focused software and reinforced the importance of testing and planning. Thank you.
Hey, it's Brendan again. So, my task for the project was the OTP, the login endpoints, backend testing, and also the backend documentation. And I worked closely with Roman to get the backend of the app all set up. Now, moving on to the libraries that were used. For the backend endpoints, we used Flask. It was pretty easy to set up as both me and Roman had experience setting up backend endpoints. I used PyOTP to generate the OTP that is used to log the user into the site. This was easy to use and also had some time-based functionality that would make the token expire after a set amount of time. Finally, I used PyTest for the backend testing. I was able to make multiple tests for each endpoint to test each case that could occur at every endpoint. Next, I can talk about the development steps. So first, we set up the login endpoints with no OTP functionality. This was just a test that the front end was able to communicate with the back end. Then I added the OTP functionality to the login endpoints. Originally, this consisted of sending an email to the user's email containing the OTP code, but we ended up switching to a Google Authenticator login. Then I added tests for the backend to make sure everything still worked while we continued development. And as I touched on before, something that deviated from the original plan was the OTP method. We originally set up an email OTP, but that did not work when we put the app on the hosting site. The free tier on the hosting site did not allow for emails to be sent, and we wanted to keep the site free, so we switched to a login by Google Authenticator. This still kept the two-factor authentication that we wanted, but it's just in a different format now. And the main challenge I faced when developing this was learning new Python libraries. I never used some of the libraries before, so it took a little time to research them and to learn how to use them. But I was able to pick up on it pretty quickly and complete the work that I needed to. The main thing that I learned from this project was how to work on a larger scale project in a group. I learned how a project like this could be split up and worked on by multiple people at the same time. This will greatly benefit me in the future when I get a job because most likely a lot of the work will be in a group setting just like this, and now I know what to expect from it.
Yeah, so I'm walking through the development of the front end UI UX, and the primary focus of this phase was to build out the complete front end, implementing secure authentication, including the login registration and logout functionality, and creating the core dashboard for password keeping. I integrated all of this with the backend at the end, using full CRUD operations for the vault. To bring this to life, I chose React for the front end. It's component based and also made the dynamic dashboard state management completely smooth. And for styling, I used Bootstrap, which was a really clean way to quickly build a responsive layout without getting bogged down and trying to create some custom CSS or something like that. And for communication with the backend vault, I used Axios to handle our asynchronous HTTP requests and also manage those API endpoints efficiently. My development process followed a pretty clear sequence. I started with wireframing to map out the dashboard structure and what I wanted it to be like. And then from there, I moved into component creation, building those modular, elements like the authentication forms and the password display cards. Next, I established state management using React hooks to securely handle that user data when it comes in. And the final step was API integration, writing those modular components directly to our backend endpoints to fetch and manipulate that live data. Of course, original plans come and change. Um, Originally, I intended to build a traditional multi-page app with something like a sidebar, nav bar for navigation, but I quickly realized that actually an SPA layout was much cleaner and already sufficient for functionality. We really only have CRUD operations and one dashboard for the user to look at, and so I realized this could just completely fulfill that requirement. And I also shifted my timeline for API integration because I relied on mock data for a little bit longer just to test that everything was showing up correctly in the fields. I ran into two main challenges. So the first was asynchronous data loading. It was a little tricky because sometimes the dashboard components try to render API requests before they finish, leading to some crashes. And I solved this by implementing conditional rendering and showing a loading state before the data was verified and shown. And I also hit some, environment configuration issues when I first deployed. I overcame this by carefully structuring the .env files within prod to ensure that seamless communication and no CORS issues with the front end and back end. So this project taught me two massive lessons. First is that data structure and alignment is crucial. Front end and back end models have to match seamlessly, or you'll constantly fight mismatch errors. And second, component reusability is everything. Breaking a complex dashboard or a single page application into multiple parts makes it a lot easier to implement. And yeah, this was a great project to kind of just see how a big project can be broken down into a team and properly implemented.
Hi everyone, I'm Roman and I engineered the backend, API routing architecture, and cloud database layer for our Secure Vault application. My first major milestone was building our core storage layer using SQL Alchemy ORM. I designed structural database models to establish clean relational links between user profiles and encrypted vault records, ensuring strict data integrity from day one. With the foundation set, I programmed and mapped our core CRUD endpoints, handling, saving, retrieving, updating, and deleting credentials. To ensure absolute data privacy, I baked in server-side defenses against insecure direct object references, or IDOR. Instead of trusting raw client-side data parameters, my code extracts the user's identity directly from the unforgeable JWT passport to verify row ownership before any transaction. For our technology stack, we utilized Flask blueprints to completely decouple these vault transactions from the authentication logic. We also selected Supabase PostgreSQL over local SQLite, deploying the entire ecosystem onto the Render Cloud platform for automated builds and real-time system telemetry. Our original production plan relied heavily on an email-based multi-factor authentication system. However, once we pushed our code to the cloud, we hit a major infrastructure challenge. Render's network firewalls completely blocked outbound SMTP mail ports, causing our login workers to hang indefinitely. To save the deployment, I collaborated with Brandon to execute an architectural pivot away from network dependencies. I refactored our data pipeline to support an offline, time-synced TOTP configuration. Now, our backend generates an isolated base32 token upon registration, enabling instant synchronization with mobile authenticator applications. We faced an additional hurdle when Supabase's Cloud Pooler began dropping active SQL Alchemy sessions, throwing random 500 server errors. By analyzing streaming cloud runtime logs, I tracked down the caching anomaly and fixed it by suppressing statement caches directly within our production connection string. This project was an incredible learning experience. It taught me how to write defensive backend code, execute log-driven diagnostics under pressure, and dynamically adapt software architecture to overcome rigid cloud hardware limitations. Thank you, and I'll pass it back to the team.
So now that the front and the back end are fully functional, we want to talk about where this project goes next. For future development opportunities, there are several. First is building something like a browser extension to handle automatic credential capture and seamless autofill right on the page, which seems to be a big feature for a lot of current modern password managers. Inside the app itself, the next step is enhanced vault organization. We want to implement things like folders and favorites so that users can manage a large number of credentials effortlessly. On the security side, we plan to monitor health and the breach detection for the security app to make sure that we have any vulnerabilities that we see, we'll be able to display it to the user and make sure that they know what's going on as well. And then we also want to have rigorous security audits and penetration testing to make sure that encryption implementation is completely airtight for us. Beyond the code, we're looking at expanded deployment and scalability improvements. There's always a way to make it run faster without traffic spikes. But ultimately, we want to kind of try and open it up to open source development. And we want to make sure that the community has opportunity to contribute and also review our code and maybe collaboratively build new features, right? Which is open source is considered one of the best ways to do that and improve our software. Looking at the bigger picture, there's clearly a lot of massive commercial potential. The demand for something like this is pretty large. I think the world runs on passwords, right? Accounts, and people want to save their passwords properly with high grade security. And so we kind of want to make sure that we build this in that way with that future in mind. And I think this has been an incredible deep dive into security architecture, state management, and full stack integration. But we have a lot of potential and a lot of things to look forward to. And so we'll continue to treat this like a learning experience and also possibly open source it, right? And see what happens. But it has been a great semester.